Hello guys, मेरा नाम जिज्ञासा है. I'm from Safal Institute and I'm currently pursuing my MBBS from MGM College, Jamshedpur. So the topic for today is magnetic field due to a straight conductor. Now we have three types in it. The first one is a finite conductor, second is a semi-finite conductor, and third is an infinite conductor. For the finite conductor, we have this wire here, which is a finite length of wire, and we need to calculate magnetic field at point P, which is here. The formula for this is mu naught I by 4 pi a, and the bracket is sin phi 1 plus sin phi 2. For the formula, we have this a here, which should be in meter. This is the a in the wire. Then the phi 1 and phi 2, these are calculated at this point P from the wire from here. And the current is I here, which should be in ampere. The value of mu naught would be 4 pi into 10 to the power minus 7, and this value would be placed here and you would get the answer. Now this mu naught is the absolute permeability. That means it's in permeability in the free space. If other medium is given, you need to calculate accordingly. Then the second here is the semi-finite conductor, and again we need to calculate magnetic field at this point P. The formula would be mu naught I by 4 pi a. Again the A would be here in meter. This is the A that you need to take. I would be the current. Mu naught value again would be 4 pi into 10 to the power minus 7, and the phi and phi 1 and phi 2. Now the wire is infinite from one side, so your phi 1 would be 90 degree. And from the other side, the point is placed at the same level where the end of the wire is there. So the phi 2 would be 0 degree, and accordingly you would get this formula. The third case, which is a infinite conductor, and you need to calculate again magnetic field at point P, which is here. The formula would be mu naught I by 2 pi a. Here again A would be this, and you need to place this A in meter only. I is the current, the value of mu naught again this, and the phi 1 and the phi 2 angle here would be 90 degree, because this time the wire is infinite from both the sides. For solving questions, usually in the question for an infinite conductor, the word mentioned is a long wire. So whenever you see a long wire in the question, you need to apply this formula. So here these are the three formulas that you need to take in consideration. Magnetic field at exit point, which is due to a circular loop. This is a short formula revision. So we have to take our circular loop first, and then we need to calculate magnetic field at point P, which is situated at its axis. So the magnetic field for point P comes out to be mu naught I 2 pi r square 4 pi r square plus a square to the power 3 by 2. Here is this formula. This r is the radius. It is the radius of the circular loop. This A is the distance from the center of the circular loop to the point where we have to calculate the magnetic field. These both values should be in meter. This I here is the current, which is in ampere. This mu naught, its value is 4 pi into 10 to the power minus 7. Now we have three cases related to it. The first case is that when point P is at the center, that means this point P is here present at the center of the circular loop. So this distance A would be equal to 0, because this point P is situated here itself. The formula would come out as mu naught I by 2r. Now this formula is for a circular loop. Let's assume that there has been a semicircular loop. the magnetic field would come out as this, half of this value. Now, this was the first case. Let's assume the second case, which is when point P is on the loop. Anywhere on the loop, this point P is present. The magnetic field would then come out as mu naught I by 4 under root 2r, because this radius would be equal to a in distance. Now for the third case. The third case is when P point is situated at a very far distance. That means this value of A is much larger than R. In that case, the magnetic field would be mu naught I R squared by 2A cubed. Simply just all these formulas are derived from this formula only by putting the values in. Now, there is a very important graph that usually comes in MCQ format. When they give you the question and there will be 4 graphs given to you, and they would ask you plot the graph for a magnetic field at an XY point due to a circular loop. So on the graph, you will have magnetic field on one axis, and on the other axis you will have the distance. For calculating the magnetic field at this point, which is at the center of the circular loop, the formula was mu naught I by 2r. So at the center, the magnetic field will be mu naught I by 2r. And then, when you started to move from the center, away from the center towards the side, the magnetic field was decreasing. The value of magnetic field was decreasing. So the graph would be something like this. Same on the other side of it. So this is the graph for the magnetic field against the value of distance, which was towards this side on the axis. So these all are the formulas